Come on, YouTube. Go live. It always takes a second to think about it, and I always think it's gonna error. Come on, YouTube. Seriously, YouTube? Oh, okay, we're good now. We're here. Hey, Sothos. I never heard of Vandermeer identity, and I don't know what a bijective proof is. Maybe that's one that involves bijective functions. My answer is probably not. That's weird. I don't really know what's happening with this. It is called Vandermeer's convolution also, which this does seem convoluted. I assume it has some helpful thing. Yeah, I mean, if you're just kind of quizzing me anyway, like I guess maybe I should put in my title at some point, but my emphasis is more like homework help. This one says combinatorial proof anyway. I don't know if it counts as bijective. Yeah, I don't know. There's many things people come into chat and like want to talk about, but I feel bad because I just don't know the first thing about it, and this is one of those things. So sorry, but yeah. Oh yeah, Gojira is awesome. Hard agree. Well, we'd see if someone pops in with a homework help question. We'll do kind of my usual filler activity and do some studying. I feel like at least starting with an E&M problem, maybe we'll do some algebra later. Maybe we'll look at this thick shell one. Okay. Spherical shell with charge Q uniformly distributed throughout its volume with inner radius R1, outer radius R2. Calculate and make a rough plot of the electric field as a function of R. So they leave this open-ended. That's kind of interesting. For how you actually get this. I think we can reasonably guess that the electric field from 0 to R1 is 0. Like in the hollow part, you can make a Gaussian solid there that encloses no charge, and Uh, therefore has no net flux through it, which is something good, I think. Yeah, can we just Gauss's law our way around this? Oh, thank you for the follow. Hey, Ren. Do you know E&M? Oh, nice. It's something that I've been doing a reading group for on Saturdays. There's on chapter 2 of this book by Purcell. It's been, the math has been so cool, but it's been it's rough to learn this for the first time. I want to look at how they I think in chapter 1 they apply Gauss's law to a solid sphere. And I want to look at that just to... Hey, Phobos. Refresh myself on how we actually use Gauss's law. Integral from minus infinity to minus infinity plus 1? I would guess that that's 0. I don't really know. The integral from... So I think that minus infinity plus 1 is basically just still minus infinity. But I guess an integral from minus infinity to minus infinity isn't so clear to me. The flux through the surface is the surface area of this Gaussian... Do you call it a Gaussian solid? Gaussian surface. That's probably a better... Yeah, I think you call it a Gaussian surface. It's just the surface area times the field is equal to the enclosed charge over epsilon naught. A Riemann sum to figure it out? Okay. So yeah, that's the thing I want to review, I guess, like that part there, like what's on the left side of the equal sign for how you actually express the flux. Okay. So we've got an inner radius, capital R sub 1, an outer radius, capital R sub 2. And I think we can make the claim for 0 is less than small r is less than big R sub 1, E equals 0. Do we want to make this a vector? I'm not going to care about the vectors, I don't think. So now we need to worry about between R1 and R2. It's a weird R. I think we can take the same surface area of whatever the sphere inside is times E is equal to. Now, do they just give us total enclosed charge as Q? Oh yes. So thoughts. I hope I'm pronouncing that right, but since it seems like you might be interested, let me. There's a whole. It's small, but there's a whole little niche of math streaming on Twitch. Let me. There's a whole bunch of links there, and I actually even have. We can add on SPQ to this list. SPQC Vitate. Let's see if I got that right. I got it right. So there should have more math streams. There's a whole bunch of people. Just the warning. Some of them do like game streams or like they'll do like a mix of things, or some of them will just play games and switch to math only someone asks a question. So I don't want to give that like caveat, but all these people like math and potentially like science related things in some way. So if you're interested in more, there's a whole bunch of people. And hello to Arush Chopra over on YouTube. Where can we send questions? You can type them out right there in chat, or if it's easier, I have a Discord where you can post screenshots, whatever your preference is. And actually, I feel like I've been remiss in shouting out Merriweather as well. Merriweather remark. But yeah, so welcome in. It sounds good. Arush? And while I wait to see the question from you, Arush, I'm going to continue on with this question, but I'll switch over as soon as I see it. Oh, yeah, that's right. I was looking at the question to see with charge. Oh, yeah, so how do we get the charge in this situation? The total charge is Q. The volume of this thing is 4/3 pi R2 cubed. Oops. I meant to say R2 cubed, but my brain just settled for R squared though, apparently. Just split the difference. Like that. But if we have something in between here, we'd have small r cubed minus r1 cubed. Okay, that's how we deal with that. Wait, well then what does that mean for Q? Do we need a proportion? Okay, let's get 1 over epsilon naught here. And then over here, I think we would do Q times the volume of our thing over the total volume. That's completely instinctual though. Like that's just, I've heard them saying why it would be like this, but it feels like I'm making a percentage here. Maybe there's, well, trying to think there's maybe an easier way to do this. So that's like maybe a little more clear that I feel more comfortable with. No, I think this is okay because you could even express it, if I thought about it in a different way, the charge per volume is total charge over total volume this thing. And so if this is the charge per volume, let's multiply it by the actual volume we have, which is the thing that I wrote up there. So I think what I have is okay. Okay, that looks like Ren agrees and Fenbox agrees. Awesome. Oh, wait, you know what? Ren is right here, and I didn't shout him out. Let me... I completely didn't even register my head, but Ren is someone whose stream I just found yesterday. So there's another math per person. Okay. So we would solve this for E. Dude, it's kind of a whole mess of symbols. I can see why in part B they give us a simplification that we can make. The 4/3 pi cancel. Four pi epsilon naught r squared r2 cubed minus r1 cubed. Okay. I think that's as good as we're going to get it. I don't imagine there's a simplification there. Maybe it might also not be a bad idea to check or what will be happening with the border points, like right at R1 and R2. I'm just kind of ignoring those. But these formulas, I think they should simplify into each other. You're shy? Oh, I see in the YouTube chat we got a question. Yeah, Ved, I remember you. If 2 pencils and 5 erasers cost 50, I don't know what currency that is, but it doesn't matter. RS, and 2 pencils and 6 erasers cost 55 RS. Find their costs. Oh yeah, sure, we can do this. This will be a system of equations. So I don't want to lose my work up here. So I translate that first sentence, 2 pencils and 5 erasers. Costs 50. So I'm going to say 2p for pencils plus 5e for erasers cost 55. So this is, you know, the 2 is the number of pencils. The p is the price per pencil. And same thing here with the eraser. So, you know, if you add up the cost of the pencils and the cost of the erasers, you get 55. We have a second piece of information, which is 2 pencils and 6 erasers. Did I get that right? Cost, oh, I got, no. This one is 55. The last one is 50. Sounds good, Arusha. I'll look at it right after this one. Okay, so there's two different approaches that we can do here. There's a math approach and there's kind of a intuition approach. I would say intuitively, between these two equations, the number of pencils is the exact same. We still bought 2 pencils each time. All that changed is we bought one more eraser from one to the other. And 55 minus 50 is 5. That's, you know, the only thing that changed is adding on one more eraser. So to me, it would make sense if the cost of one eraser, 6 minus 5, is 55 minus 55. I think that one eraser is going to cost 5. We can show that mathematically, though. There's a few different ways that we can solve a system of equations like this. I'm just going to guess that you were taught substitution, so I'll do it that way. Because I feel like I was taught to do it a different way, but I feel like many students weren't taught that way. So I'll try and do it a different way. I'm going to take this equation and I'm going to isolate, let's just isolate P just for fun. So I'm going to subtract the 5e over 50 minus 5e, and I'm going to divide each side by 2. So P equals 25 minus 5 over 2e. Yeah, Arush, that's the way that I was thinking of. I just feel like a lot of people don't learn that. So I mean, I can show it that third way too, or that way too. But going with this substitution way, we know what P is. So let's go over to our second equation and plug it in for that P there. So we would get 2. Now P we know is 25 minus 5 over 2e plus 6e equals 55. Multiply the 2 inside to each of these, you get 50 minus 5e plus 6e equals 55. Now subtract the 50 over, and I'm also going to do negative 5 plus 6 is 1e. 55 minus 50 is 5. So we do get that each eraser costs 5. Perfect. Knowing this, we can plug it back into either of these equations to get what P is. I'm just going to use the first one because why not? 2p plus 5 times we know now e is 5 equals 50. 5 times 5 is 25. 2p, subtract the 25 over to get equal to 25. So p is 25 over 2. I don't like that's not a clean number, but that's what we get. Yeah. And that's also the same thing as, since we're talking about currency here, I might call it like 12.5. Give a decimal rather than a fraction. Hey, Eldritch! New magic runes? Yeah. Yeah, Rush, I agree. That's kind of like the intuition thing that I let off with. So the answer from this is that a pencil costs 12.5 and eraser costs 5. Let me show the different way of solving this so that that's going to be a lot quicker. Not everyone was taught this though, which is why it wasn't what I led with. But I was taught that this way that I just did is called substitution, and this way that I'm about to show is called elimination. We'll just write the equations right on top of each other. And I see we have a 2p and a 2p, so I'm going to subtract these two equations, and it actually works. 2p minus 2p is 0. 5e minus 6e is, be careful with friends. We have 5e minus 6e, so we get minus just e. 50 minus 55 is negative 5. So minus e equals minus 5, and multiply each side by negative 1, you get e equals 5. And now you can do the same exact thing like I did here with like plugging in 5 for e to get p. So I hope that helps, Fed. Sounds good, Eldritch. Simplify the solution? Okay, cool. Bringing up the problem you just posted. Five streak, nice. Thank you, thank you. Ooh, what's happening here? Surely there's some kind of symmetry or a trig formula we can take advantage of here. So pi over 4 plus pi over 6, that does not make a clean unit circle value necessarily. Good thing it's finite? Yeah, Ren. Because you have just pi over 4 plus pi over 6. Is that going to be 5 pi over 12? Okay, yeah. So I'm definitely looking for trig identities. Can we do the product to sum? Would that solve all our woes? Not necessarily. Maybe, though. I'm looking at this identity down here. But I wonder if there's a different way that we can do it entirely. Would we get anything good if we did the more common sum identity here? Oh, actually, you're probably supposed to do that. Yeah. I sort of hesitated to use product to sum because not everyone learns them. They're a little bit vague. But I think this identity is going to be helpful too, potentially. What I thought to know is that a minus b is pi over 6. I'm not sure what, like, a minus b is in this case, but I think I'm going to try using this sum identity before anything else. I have a bit more faith in the product to sum formula, but I like to avoid it if I can help it. So I know I didn't learn as part of my trig class. Oh, okay. Pi over 4 plus k minus 1 pi. Six times sine pi over 4 plus k pi over 6. Okay. So how does this sum identity work? You do sine theta cosine phi plus, okay. So applying the sum identity to that first sine, I need to come down here for it. We're going to get sine pi over 4 times cosine k minus 1 pi over 6 plus, now we switch them, Okay. And we might get something vaguely nice here because sine pi over 4 and cosine pi over 4 are the same thing. Not quite sure though. Applying it over here, it'll be the same form, just k instead of k minus 1. Okay. After this, you multiply numerator and denominator by sine a minus b. Oh, really? You got some cotangent stuff. Let me see how this kind of shakes out before I look too hard at that. Okay, so sine pi over 4 and cosine pi over 4 are root 2 over 2. So we can factor root 2 over 2 out of this term. We can factor root 2 over 2 out of this term. Root 2 over 2 squared is just 1/2. So I'm just going to stick a 2 in the numerator because the 1/2 is in the denominator. And after the dust settles, what do we get? I was about to spell out pi for some stupid reason. My brain doesn't work. Do we multiply these? Do we get a Pythagorean identity? No, I don't think we do get a Pythagorean identity. Let me just try and update you. Sounds good. Yeah, there should be some type of pattern that we can get to here. I'm hoping to get that cancellation just via trig identities. It might not be so easy to actually get that, though. Because like the thing about each of these, like looking just at this part in the parentheses here, but this also applies to that part in the parentheses here. We're taking multiples, we're taking sine and cosine of the same pi over 6 multiple. So our options are 1, -1, and then plus or minus root 3, plus or minus 1 all over 2, I guess. So that's not actually, and you have the same, you're also multiplying that by the next pi over 6 multiple. So maybe, yeah, that's really not so clear to me how we get a cancellation with this. Let me try my product to sum formula. Cosine theta minus phi minus cosine theta plus phi. Cosine theta is that entire thing. Oops. Minus whatever's inside the sign, I think. And Lux is getting 8 over root 3. The first 12 terms cancel? Oh, interesting. Oh, can you pair these up in a clever way? Yeah, that must be it. Sounds good, Arush. Yeah, this thing is going to repeat itself every, like, 6th value of k. I'm still curious to see how that... You're getting 2 times parentheses root 3 minus 1. Okay, so we do have conflicting answers here. We can get the right answer from Wolfram, but I don't want to do that yet. I want to apply my identity here and just see how it looks. Senior citizen now, 65 streak. Nice, Jed. It's a 2 on top, by the way. Minus that thing. Minus cosine of these 2 things added. Oh, the pyrophores don't cancel on this one. That's really annoying. I'm much less of a fan of this identity now that I've realized that. We do get k pi over 6 minus k pi over 6. Wow, because actually this first cosine, it simplifies just to minus pi over 6. That's kind of amazing. The second cosine is not going to be nice, though. Ooh, maybe with a sine identity it would settle down, though. This now becomes 2k minus 1 pi over 6. Probably translate it into a sine with an identity, because that's pi over 2. Interesting. Longest streak you've seen so far? Yeah. Yeah, Rush, please do. Since my thing isn't as I mean, I think you can do something with the thing that I wrote in red, but I want to see what the answer is, so I know that going into looking at these solutions. Or at this solution here. Sounds good. Critical? Oh, you got the right answer. 2 root 3 minus 1. Yeah, please do. Hmm. Just bringing these up to look at them. I don't want to get too far away from Arusha's question yet, though. My favorite math course in undergrad. Um, they called it Methods of Applied Math, and it was basically just differential equations extended. So we're towards the end. My favorite thing we did was systems of differential equations. Sounds good. Critical. A graduate version of that this term. Oh, cool. I'd love to study it more. Oh. So no identities you can even possibly use for this problem. Yeah. Just seems like a natural thing. You're looking. I mean, it's not a particularly creative idea. You shouldn't feel like you can't do it. Or like in general, anything I do on my stream, it's like a lot of my stuff is just copying other people. So gotta think about something else. Well, it's like there's another math streamer named Penn Center who like um he was gonna do the Greek letter thing too until he saw mine, and he did instead he did polynomials, like the graphs of them of different degrees. Like your 1 month is a line, 2 month is a parabola, all that stuff. Hey, it's G1. Told your GF to make this badges. She hasn't started. Oh, okay. Yeah, I'm glad that the sub-badges are small because I made them myself, and it's if you really dissected them, they're probably not too pretty. I was like, I wish might need a minute to post the solutions. Maybe I'll start looking at criticals. Um, The grammar of this second question is messing with me. Find the general solutions of the system whose augmented matrix are given. I think it's actually correct grammar. I think it's more natural sounding to say is given because the word right before it is singular. But I think the R refers to solutions. But no, the augmented matrix is what's being given though. No, it should be is given. Yeah, that's a weird thing. I don't remember grammar school well enough. Or like grammar class well enough. Yeah, it kind of is the worst. It should be, yeah, I think so. This one I definitely know what to do. The second one, there's 4 vectors here, so isn't there not going to be a solution? I'm not sure if Hembox. We're just gonna post their solution at some point. 3 is pretty. I feel like for 2, there's no way. Okay, I want to keep that one open. Wolfram that made the mistake. If Wolfram starts making mistakes, then we're in real deep shit. Wait, so I should have not chosen an n by n matrix. Right. Okay, each one of these is a row, comma, column. Wait. Yeah, across, okay. Sorry, each one of these is a column, and then you go down 1 row. Okay. And I was gonna put in number 2. So we have 5 columns. So we need 4 commas. Been doing math long enough to know not to bet yourself too highly. Oh, is Wolfram even going to know to do this like an augmented matrix? Do I need to give it as an equation? I'm not going to know how to interpret Wolfram's output for this, I think. There probably is a way to do it well. And it's not going to stop me from still just plainly giving it the matrix and hoping that it gives me the solution anyway. Oh, you're here critical. Okay. Pseudo inverse. I don't know what that is. Yeah, it's not. Just in your solution, Rushed. I don't see it in the Discord. Maybe. Yeah, I don't see it, but. No, I was saying to Arush, I don't think these will, okay, it's not gonna be a solution. So, I mean, for this first one, I don't think there's a trick critical. Like it just, you have to do the row reduction stuff, I guess. I don't see a trick anyway. I mean, for number 1, it's just doing the work. I don't think it's going to be anything special about how I do it. It's going to take a lot of time. Um, like I noticed that like along column one, the X ones, like this one came multiplied by 2, that one came multiplied by 4, and you have an easy cancellation with the 4 up there, but you still just have to do your good old row operations. I'll take a look at the solution in a second, Arush. For number 2, oh, you found it? Okay, well, hey, it's better than never finding it. Yeah, Arush, I agree with what you're saying. Like, no, number 1, like, it's not conceptually difficult what you have to do, but it's a lot of calculations to have to do. Like, I don't think there's a trick for number 1 to save time. I don't have one, at least. For number 2, I think you should be able to just say no just by looking at it, because you have one too many vectors here. Where do you begin with number 1? I mean, I would put it into an augmented matrix and start doing row operations. I don't know a faster way than that. You should be able to get some solution from this. It must have just been a calculation error at some point, because that's more or less what I would do too. Actually, Wolfram probably would rather have me give it a vector here, right? No, Wolfram doesn't like that. It's even too tedious to put into Wolfram. I want to put the first one into Wolfram now. Yeah, I mean, you can technically, like, take the inverse matrix of this thing and then multiply it by the solution or something like that. No, that only works for 2 by 2, doesn't it? Or does it work for this also? I mean, yeah. Okay, yeah. So you could find the inverse of that 3 by 3 matrix and left multiply each side by it to avoid row operations, but like, getting the inverse of a 3 by 3 still isn't easy. Tricked you? Like, in what way? I could actually make Wolfram Alpha do that inverse thing so I don't have to do all this typing. Oh, that's a stupid inverse. Actually, wait. Oh, that's how you make it do what you want. I see. You need some good old RREO. Ah! Waffle, you scared me. So yeah, Critical, if you do go through with the operations, you should get that. You know, I forgive you, Waffle. No. In every shop, if you have like I think Critical just has to solve this with row operations. But I think there is technically a matrix way to do it. It's just not very clean. But yeah, there. Not clean. The way like I think row reduction is the best way to solve this. There is a different way to solve it technically, but it involves finding the inverse of the 3x3 matrix from this side and then doing matrix multiplication. And the inverse is really ugly. It's number one, by the way. Critical, it's the same as you. Put it into I went to matrix, switch rows 1 and 3, and then try to eliminate the x1 from the last 2 rows. There is no trick here. It's just doing the math. It's a really tedious problem. That's why I don't really want to do it. You get 0 in the second. Well, you start with a 0 in the second row, second column. But once you subtract off row 1, you're going to get a -4 there. Actually, you're going to get twice that because you're subtracting off 2 times row 1. So you're going to have a -8 in that 0 after you start subtracting things. Problems 25 minutes. Well, the other 2 problems are pretty quick. Like number 2, you can solve it by looking at it. Or you can say there is no solution just by looking at it. I mean, yeah, the first one definitely takes the most time. The second 2, like maybe there's some conceptual stuff that's, it's more testing the concepts, I guess. But the first one, it's just a lot of arithmetic. But yeah, it sounds like you're asking me for a trick to do it, and there isn't one. Just try not to make a mistake. That's the only thing you can do when it comes to row operations. Unfortunately, I wish it wasn't like that, but... What's up with the Risha's solution for the previous problem? So you're calling one of the inputs A, the other input B. You multiply it by sine of A minus B over sine of A minus B and apply some identities to get that thing. Hey Mibsum Ahmed, do you do mechanics? Not really. I'm really terrible with mechanics, I'm sorry. I mean, I noticed that too, Jed, but I think the work over... I don't know if that really saves work. It maybe makes you less likely to make a mistake, but it feels like the same amount of work to me. What Jed is saying is that in the second equation, there's no x2. So you could, in theory, try to manipulate the first and third equations to get something without x2 as well. And then you can figure out x1 and x3 just as if it's two equations and two unknowns. But I think that involves enough work that... That's not what you're saying? Okay. X equals 2, z is -1. Yeah. Oh. Okay, it amounts to the same thing, but yeah, you're right. You can do that. I don't view that as less work, but it is like maybe more intuitive. Arush says there might be an easier solution that they're about to send. Can you reduce numbers from the matrix? Yeah, you're allowed to multiply a row by -1 as much as you want. It's valid. You can hate Dr. L. Multiplying R1 by 4? Why would you do that? Let's see where this goes. And then what's happening? Is that's supposed to be a 3? You're adding row 1 to row 3? So we expect a 17? It's a little bit messy, but I think I'm following. Then a 0 down there. 18. So you're initially getting a 0 in the second position in the third row, I guess was the point of this. Oh, and then because you have the 2 zeros here, this is like a similar idea, a different way of doing it, but a similar idea is what Jeb was saying, is to get an equation with 2 unknowns, or 2 equations with 2 unknowns. Which does get the right answer, but I mean, I just don't think it's tedious, but I don't view it as that much better than just doing the 3x3 row, or I guess 3x4 row operations. At that point, I would call it just a style thing for what you prefer to do. So I think for some people it's faster, for some people it's not, is what I'm trying to say. I mean, I think a system of equations has an important use case. Like, it's good to know how they work, because they do come up. I think, I don't know. You hate solving systems of linear equations, it does not excite me. Yeah, I agree. It's really boring. Like, I feel like students shouldn't be tested on super tedious ones that are just better done by a computer. But I do think it's helpful for students to know how to do these, like the process of it. It depends on the class, Arush, whether you can use calculators. In the real world, yeah, you certainly would just use a calculator, even for relatively simple ones. But I mean, it's still important to remember, like, to know fundamentally what the computer is doing. I think, at least. Probably nothing exciting. Yeah. So gave us a 4x4 and you took introductory linear algebra on the exam. Oh my god. To get the inverse of? Or just to do RREF? Either way, like, I don't think students should be getting something that's that hard or that, like, tedious. Like, oh, okay. Just RRF, yeah, that's still super annoying, but you want to go to UCB to study math? Is that UC Berkeley? I guess good luck. I imagine it's pretty competitive. I think I'm gonna get back to E&M here unless someone cracks open the cold case for one of these questions we were just talking about. Planning to get into a bachelor's. Oh, I'm planning to get into IIT for bachelor's and then go to UCB for master's. Okay, cool. I think like black pen, red pen. I feel like he went to UC Berkeley or something. I feel like I remember him talking about it in a couple of videos. Indian Institute of Technology. Oh, nice. You love black pen? Yeah, he's awesome. Really fun videos. Okay. So we were working on this E&M problem. We were doing Gauss's law. We figured out the field for the first two intervals. We need to figure out the field for outside of this thick shell. And I think that's just the Gauss law application can be pretty similar. But I think even simpler than the case above, because we're going to do times Q. This is just Q. Because Q is already our total enclosed charge, isn't it? Yeah, it's just going to be the same as like a point charge, I think. 4 pi epsilon naught r squared. I think that's okay with me. Good stuff, glad to hear. We need to make a rough plot of it. So let's do a rough plot, I guess. So our significant kind of boundaries are going to be R1 and R2. We start at 0. I'm still not sure about the border points. Exactly at R1 and R2. I'm going to guess exactly at R1 we don't have a field. I don't have a good explanation for that though. Actually, it's going to be continuous anyway. I'm going to guess it's continuous. If R equals R1 up here, we do get 0, or sorry, right here, we do get 0 for the entire field. So yeah, this is going to be continuous, at least for that one. Now this, well, like, what is this? It's a rational function, a cubed over a squared. I assume the book would do some kind of approximation here, because I don't really know offhand, but can I say it's going to be approximately linear? I feel like we can say that. Because I'm just kind of going vaguely off. We have cubed, we have squared. So if you were to do that cancellation and ignore the rules of math, that would come out to be just to the power of 1. And that makes sense with, if this was solid, when you're inside of a solid sphere, your field does increase with R. And then once we go outside, it drops off with r squared. So I'm gonna, how does that look though? Is it gonna be like that? I think so. Something vaguely like that. Actually, we should check if he's actually, if there's a discontinuity there. So if r equals r2, this cancels with that, and we get basically, okay, yeah, so these are, this is all like continuous. Okay. That's my rough plot, I guess. Yeah, I did say rough plot. And then the part that involves chapter 2 math is part B, I think. Because that was all chapter 1 stuff that we just did. Potential at the center of the shell. So if we have field and we want potential, I think that involves an integral. We do E dot ds from infinity to 0. Yeah. I think we want this little thing. Okay. And we can just approach from a radial direction, so we don't have to worry about any crazy dot product stuff. And we do get to take R2 equal to 2R1, which will be nice, because it looks kind of annoying to integrate otherwise. Okay. Actually, let me buy a bit more space for the whiteboard and do that. I don't know if I should put a subscript in that fee. I'm just not going to do it, though. Infinity to 0. We got to split this baby up into 2. Infinity to R2 of the field outside of R2. dr minus from R2 to R1 of the field for that part, which we're going to need our approximation. And let's actually go straight to using 2R1, because I don't want to do all this writing to do it twice. So if R2 becomes 2R1, we just get an R1 cubed in the denominator. Like that. Arush, you're out of here? All right. Thanks for hanging out. Good to have you here. All right, so this integrates directly. This, we need to split into 2 fractions. And there technically is a third integral, but we're integrating 0, so who cares? Actually, wait, I said this integrates directly. The minus sign I'm going to absorb inside the integral and flip the bounds However, we're going to get another minus sign from integrating 1 over r squared. I'm also going to factor out q over 4 pi epsilon naught. Yeah, that's okay. How does that thing, the q over pi epsilon naught is factored out. For one fraction, we have r cubed over r squared r1 cubed. So that's going to become 1/2 r squared over r1 cubed. Because we're basically just integrating r over r1 cubed. And then we're going to come over here and do minus. The r1 cubes are going to cancel. So we have just... There's a minus, and we're going to get another minus from there. I'm doing a lot of mental math here, but I think I followed it okay. Let's see if it gets us to an answer that vaguely makes sense. Zero plus 1 over 2r1 plus. We get 4 on top, cancel, so we get a 2 for r1, I'm going to say. For that with 2r1. I think it's okay. 2r1. Cancels. What's happening here? One over 2r1 minus 1 over r1. Mistake? 7r cubed in the denominator. Or 7 factor. Where is there a 7? Oh yeah. That's born of many... Oh shoot, my cam blocks that. That was born of many a time that I wasn't looking at chat and did the and continued on with a mistake in my math. I don't see where a 7 is coming from. Two r cubed minus r cubed. Oh, I can't do math. Yeah, when I plugged in 2r1 here, I didn't cube the 2 as well. So it's 8 r1 cubed minus r1 cubed, which is 7 r1 cubed. Okay. Can I just be lazy and multiply each of these by 1 over 7 though? I think it's okay. So that become 2 over 7 R1. I mean, oh, I accidentally erased the 2 R1 from there. That one's okay. Now over here. 1 over 14 R1. The numbers are so much uglier now. I preferred it with the mistake that I make, so the numbers were cleaner. Okay. These two still canceled. That can subtract with that. Okay, let's see. It makes sense. We shouldn't get something that's too clean because of this weird setup that we had. So we get 9Q over 14 times 4, 56? Because 5, 6, yeah. Sure. Oh, we can take... one over 0, the forbidden ratio. And I'm just going to chop off the sub 1, because that's what they say you can do. All right, let me catch up with chat here. J Raj song, I see you retracted message. I didn't see the original message, but welcome in. And entropy, yeah, I solve math questions. I'm doing this physics studying in the meantime while there aren't math questions, but that is my shtick. And Kaustav, track robordy. The theme I stream is I solve homework questions from chat, and sometimes I look around on the internet. And if there aren't questions to work on, I do some self-studying. And my self-studying has been electricity and magnetism, which is what I've been doing just now, or sometimes I do abstract algebra. So, yeah. You liked part A, you don't think you followed part B? It was really just integrating the result from part A. Like, is it like the setup finblocks or just the execution? Okay, well, the idea is I want to integrate from infinity to 0 to get to the center of the shell. But the field changes depending on the value of r, so we have to split up into 3 different integrals, but one of them is 0, so I didn't write it. Let's see if the book agrees, I guess. Number 10. Okay, inside is 0. Well, that feels like a cop-out, but sure. Okay, and they do calculate what Q sub R is. Good. And I get the same. Wait. They multiplied this R squared into that. I hate. Oh, it makes the integration easier, I guess. Okay, sure. Oh, okay, and I noticed this part on my own, that being proportional to R matches a solid sphere. Oh, wait. What? Oh, that's not linear. It's only... Oh, interesting. It's linear minus one inverse square. It is a shark spin, you're right. Okay, so what I didn't do in my head is I didn't distribute I counted for that R cubed over that R squared, but we do have a constant over the R squared as well, which I forgot to account for. That's why I thought it was linear. Okay, and so why would linear minus inverse square look like that? Let's look at Desmos. Just want to understand what's happening. X minus 1 over x. Like, I feel like 1 over x squared. Well, ooh, that's a cool looking graph. So we're on the early part of this curve. Interesting. That makes sense, because 1 over x squared is actually only significant for small values of x. For big values of x, it's almost not even there. Okay. I had it backwards in my head, which is why I was confused when I was looking at Desmos. Okay, so that's a mistake there. It's 1 mark off. Hey, Renga. I mean to set something up like that at some point. I haven't, though. I'm working on an electricity magnetism question for like self-setting. I can show it in a minute. We're looking through the answer right now. It said rough? Yeah. They really need to define rough. Otherwise, I'm saying my answer is still right. KQ over epsilon naught. Well, the K already includes epsilon naught, so... Right? Yeah, it'll be KQ over R squared. But yeah, basically. You don't fuck with that stuff at all anymore? The math behind it is so cool. When I took this class as an undergrad, I was not a fan. It didn't go as deep as this book does. But I took like E&M with calculus light, I guess, as an undergrad, and I hated it. But this has been so much fun now that I know multivariable calculus. 9 over 14 over R. Hey, it matches. Boom, 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 boom. Dude, I think every time I hear boom, I think of Merriweather going boom, 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 boom. The branding is working, or you know, whatever that is. The catchphrase. We write this as 9/7. I really like the answer key because they like kind of discuss like the next evolution of it too, or like they usually include something that I never even thought about. You took this class in undergrad at the same time as Calc 3, about 2/3 of the way through. Name classes like, also, we've just been doing these flux integrals that you just learned about in Calc 3. Yeah. The class that I took was only single variable calculus. And I think that's part of why I thought it was so lame. Like, it's just so much cooler when you're allowed to use Calc 3 stuff. Highest grade in the tutorial session yesterday? Oh, congrats, Joseph. And the 5-watch streak. Thank you. Whoa. If you write this out as 9/7, we take a 2 out of the 14 and put it with the R. It lies between the factor of 1 for a thin shell of radius 2r and the factor of 3/2 that is relevant for a solid sphere of radius 2r. 9/7 is between 1 and 3/2. Oh yeah, Ranga, that will make it a lot harder if like maybe they called it like a co-requisite, but it really should have been a prerequisite. Yeah, I probably wouldn't enjoy that experience of being expected to already know Calc 3 on day 1 of E&M. Trust my physics intuition. I don't know about that. Nice to know, it really would have helped. Oh, okay. Yeah. I only started enjoying math when I took my first calculus class and I realized how the stuff I was learning in my calculus class directly applied to the stuff we were learning about in physics class, but neither classes actually talked about it. I realized it on my own. And it would have been a lot cooler if they did. But I was like in high school. I don't think I was even taking AP physics. It was just normal physics. Yeah, I'm kind of happy with how I did on that problem. The part A was a nice refresher on Gauss's law. In part B, I mean, the formula thankfully is relatively simple to apply there. If I had if I was able to speak, I'd love to say so many things. And if I had infinite time, I'd love to just solve like every single problem in this book. I don't know. These are just really cool. Oh, I thought you were like cursing and censoring yourself. I just realized that you meant 2-star problems. Yeah, um So some of these have been pretty brutal. So like I think that one is just an easier one. I'm gonna struggle much more. I mean, even with potentially like 12 right here, I'm just doing whatever the next one happens to be. Consider a ring with charge Q, radius R. You get a cough drop of radius R as well. Great problems can solve themselves. They're so great. Son of a bitch! Wait, it cut off! Stream is cutting off my alerts. I don't know. Stuki, thank you so much, though. It was great to watch your stream. Hope the last part of it went well that I couldn't catch. And welcome in, everyone. Earlier we were talking about some, we're doing some like linear algebra, row reduction stuff, as well as some like trig, summing, sine stuff. There were questions from chat, but since things have slowed down, we're doing some E&M studying. Pretty pleased. Yeah, it's interesting that you're going to be like giving a talk there. 212 is pretty simple. It's the A part. I still haven't read all the way through Syed, but yeah, really. Workshop the punchline for that talk. Ooh, do tell. I was pretty proud of my phobelian pun. I did have to Google how you spell faux because I couldn't remember, but I was just reading problem 12, so I had just done the problem. I had just done number 10. PB point distance x from the plane of the ring along the axis through its center. Half-measure from all pieces of the ring, find... I feel like I did this in chapter 1. We can do it again. I don't think it's that hard. It seems like it's going to be part of the point of the problem, looking at B and C, so... Oh, this is the exact same as the problem in chapter 1, except we're doing it a different way. I remember showing that it's, or almost the exact same. Like, in chapter 1, I think they made you find the harmonic motion. No, but that's my workout routine. I lift a weight once, and I think that I'm forever exempt from lifting weights again. Oh my god. Oh wait, I'm not charging my phone. Now I am. Dude, I hate... I don't mind working out that much. I do mind going to the gym. And it's completely, like, my own problem. I just don't like that there's other people in the gym also working out. I want to have my own personal gym, I think. There's always, like, one person hogging the exact machine that I want. And I'm too awkward to ask if we can, like, trade off on breaks or whatever the customary thing to do is. So I just kind of, like, silently try and do other parts of the workout until they stop, but then like they just never stop using it. So Anyway, ring with charge Q, radius R. Leave the gym. That's basically, yeah, that was my custom as well. And I say that like I've gone to the gym recently. I haven't tried to go to a gym regularly since like high school. Hey, Umang Kumar, welcome in. X. Okay, not exactly punch without the rest of the talk. Oh, okay. Semi-direct products. Okay, wait. Well, let me sit down again and read this. That's rare, but it's a little bit too hard to describe without the context. Semi-direct products admit a universal enveloping construction, which a PBW theorem, which admits PW theorem precisely when they look like the Weil algebra. Oh, wait, so is it not an actual joke, or am I not getting it? When you said a punchline, I was hoping for like some kind of like pun or something. My bad if I misunderstood that. Oh, okay. But like, you know, some kind of nice like wrapping it up. That's cool though. Oh, I did see on one of the websites you're looking at that they said like a wild algebra appears when they were talking about wild algebras, and that kind of made me laugh. Yeah. How does this thing work again? X is fixed, or we take it as fixed anyway. The total charge if we have this bar is in my way. What we're we're taking a very, the Q is in my way too now. Very small part of the ring and calling that DQ. And DQ is something, I'm sure. Equally proud and ashamed of that one. It's the density, I guess we would call it lambda. Shouldn't it be a linear density? I don't really know if that's all that important. I feel like I'm... What's the circumference of a circle? 2 pi r. I knew that. There we go. So yeah, that makes sense if we want to use lambda here. So this would mean that dq is 2 pi lambda dr if we multiply each side by 2 pi r. Except we're going to want to work in terms of angles here. Are we not? Actually, wait. R is never changing. How did I do this? Are we varying theta? This is for the entire ring. But would we actually say that dq is equal to lambda r d theta? I think we do. Because 2 pi is the entire ring, but we actually want to vary that 2 pi, weirdly enough. So I should have called it theta. Well, no, I mean, it's accurate for that part. Anyway, I think that's what we want. If we Coulomb's law this thing, zero to 2 pi d. I meant to write q. 4 pi epsilon naught r squared. 0 to 2 pi. So dq. Oh, that's terrible of me to have written. I'm just going to leave off the bounds so I don't feel like thinking about the bounds for dq. Lambda r d theta. 4 pi epsilon naught r squared is big R squared plus x squared. We need a cosine theta. Yeah, right. If you're talking about cosine theta, I definitely agree. If there's more, I mean, I would believe it, but... Epsilon naught. I forgot the cosine theta a second time. Okay, there. Okay. Am I being sloppy about how theta is defined? Because I was thinking theta is like the angle on the ring. Like I was saying that theta is this angle. X isn't involved at all in that theta. I feel like it should be cosine theta, but I also can't make a justification for that. And I feel like that's a pretty strong argument for why I can't do that. Yeah, I think I should make that like phi or something and do what Fembach said. Because we actually, we would call that one like phi or whatever. The angle is a constant. Yeah, okay, this makes sense. Okay. Because like that angle phi, it's not changing. Okay. So all that really happens in this integral is we multiply by 2 pi. We don't have any thetas anywhere. Sometimes I catch myself, and not always. Lambda Rx 2 epsilon naught r squared plus x squared to the 3 over 2. Is that what I'm claiming is the answer for part A? I think so. Every angle must be theta. Yeah. In the same manner, find the potential phi of x at point P. I better integrate it? Is that not what I did? Okay, yeah. No worries. I think the formula is nearly the same, but you have just over R. If we're using this formula here, except in cylindrical, or, well, polar, I guess. How does this work? I guess it'd be cylindrical. It's cylindrical, but R is fixed, Z is fixed, which Z is X here, confusingly. X equals 0 and X approaches infinity, you want to think about? Well, if X is 0, the field is 0, which would match with like being inside of a shell. If X approaches infinity, it's approaching 0, which makes sense. Because degree 1 on top, degree 3 on the bottom. Yeah. So to apply the formula, why are you multiplying it by R? Are you still talking about the equation for the field? Okay. I mean, I think to do this integration for phi, I feel like I'm trying to justify why I can't just do the same thing except with just R here. I feel like there's maybe some type of extra factor that we get converting this thing from rectangular to cylindrical, I guess is my worry. But would it be the same factor that we just got in the first one? And my worry is for nothing. See, it's not as intuitive to me as the one for field is, I guess. No, I don't think we do get the same cosine. Well, we're only integrating over the ring itself, I think. Well, this is that thing with like whether r is a variable or constant. We're holding x is fixed. Hey, Missy. Yeah, I majored in applied math. I think this integral takes care of from infinity to x for us. Does it? Nice, you're doing computer science plus math right now, no questions. Oh, cool. Well, thank you for saying hi. And yeah, that's a combination that I did. I did major in applied math, minor in computer science. Computer science, I've forgotten way too much of it. Shouldn't quant at all? I haven't really studied it specifically, no. I mean, there's probably some cool stuff that I would be interested in, but I don't know too much about it. Oh, right as I click away. Yeah, I was looking at 2.100. But I want to find it in the book to see the explanation for what this formula is again. So the x prime, y prime, z prime is something. It's the contribution, or yeah, $5. It's just whenever I'm really struggling with the row and the primes in this formula. It's been a consistent issue for me, I feel like. And sometimes the R, I guess, and the other, like, I think with like the line problem, that was an issue for me. Yeah, actually, probably with my integral for part A, they're probably just gonna say they're probably not even gonna do an integral. They're just gonna say that the total charge is 2 pi r lambda. Is that okay to do here? Mm. Oh, good. I'm gonna reuse phi also. Ugh. Why do they reuse so many of the Greek letters for different purposes? Phi is for potential and for angle sometimes. Like, what I wanted to say is that total charge is 2 pi r lambda over 4 pi epsilon naught. Small r is root r squared plus x squared, and we need to multiply. Do we need to multiply it by that same thing? I feel like we actually don't. I think that this is fine the way it is, aside from the cancellation. And we're going to check it in the next step anyway. So we're going to take the derivative with respect to x. Rho dv equals... Okay, yeah, let me look at what you're saying. $10. Dx dy dz equals r dr d theta dz. We really want theta to vary, right? Right. Rho dv equals sigma dA equals lambda ds. Hmm. Whoa. Yeah, I was trying to work out the constants in what you were writing. There might need to be an R there. But also just looking at it, I think the derivative is actually going to work out here if we just blindly do it. I mentioned what you're saying, Fembox, but I kind of want to try this derivative. So I think it might actually work out. Because right, it's just on my mind right now, so I want to... r lambda 2 epsilon naught root r squared plus x squared. I think what you're saying is important to know, though, Fembox. I just like... I still notice I think this derivative actually works. So power rule, we multiply by -1/2. And that negative cancels with the negative out front. We're also, because of chain rule, we're going to multiply by a 2x, though. So the 2 and the 1/2 are going to cancel. We get just an x in the numerator. And then the power of this thing increases by 1. It does match. Okay. So I just want to make sure that was the right result, I guess. Okay. I want to be better with those like differentials though, and going and switching between coordinate systems, because it does seem important to be able to do that, and I've been consistently struggling with it, at least in this context. And it's like part of the issue is that we have like that volume integral, and we have to convert it into a single variable integral because things just aren't varying, or two of the dimensions aren't varying, and that part's always weird for me too. Maybe it's just better to remember the geometric interpretation of what it actually means. It's really just trying to get the total charge. I don't know. What does part D say? Charge minus q with mass m is released from rest far away along the axis. What is its speed when it passes through the center of the ring? The last thing I saw from your pen box is sure, keep going. Before that. And before that, you said got the potential on line 3. Oh, so I noticed in the integral for the field, all I wrote is multiplied by, it was just the total charge of the ring. It was 2 pi times lambda r. And I was just kind of assuming the integral for phi would result in the exact same thing. I was trying to justify that the entire time in my head, which is what I was struggling with, but I did a shortcut of this. Instead of actually doing an actual integral, I just made the claim that that thing right there is 2 pi r lambda, and that's going to be the result of the integral. And I think that's only okay to do here because that r is constant. But yeah, there's been a situation where it wasn't constant and it wasn't important, which is why that's part of my issue. The other part of the issue is like doing the actual conversion like you were trying to do there, or actually doing, but like I couldn't really show that formally to be honest. Oh, I zoomed out, I guess. No. Ah. Thanks for nothing, OBS. Okay, I mean, I guess I'm gonna start looking at part D. I don't know. Charge minus q with mass m is released from rest far away along the axis. What is its speed when it passes through the center of the ring? Well, we know the field, which means we can figure out the force. It was just multiply the minus q in. And we set it equal to mass times acceleration. So the issue, I think Bladby has pointed this out before, is that Acceleration is the derivative of velocity with respect to time, not with respect to position. And that makes this, I don't remember how we dealt with that. Because it would be natural to me to just integrate this thing from infinity to 0. But there's a sneaky way to deal with it. I assume there's some kind of parameterization, or like we can convert that time into position. Chain rule? Let's start writing things out, I guess. Oh. Interesting. Okay. A equals dv dt. And dv ds times ds dt. And ds dt is just v. So then A times ds is equal to v times dv. I guess I'll use x here because we're using x in the problem. But yeah, s is more general for arc length. Interesting. Okay, so where does the problem? Okay, I can go a bit further left of that dot. Can I go like there? Okay, that's like the border where I can go. Okay. So if we plug in for A here and integrate each side, from infinity to 0 minus lambda rxq over 2 epsilon naught r squared plus x squared to the 3/2 dx. M. So I assume when we integrate v dv, we're gonna get 1/2 v squared. Reinventing the wheel here, but you can totally do it this way. Oh. Oh, wait. Is it better to do it with energy? Because we know phi is the potential difference. Yeah, okay, that's probably, we would take the potential difference, multiply in the minus q, let x be 0, and set it equal to 1/2. Ah, okay. That, that's a good call, right? Actually, I don't want to erase this, though. I forgot. Phi, it's almost potential energy. Root r squared, because we're taking x to be 0 to 1/2 mv squared. The r's cancel out entirely, which is kind of interesting. M equals v. Oh. That minus sign kind of throws a wrench into the... I mean, we'd have root r squared. Who would have contact for wheels? Yeah. Can we somehow justify taking negative r for the result of root r squared? I don't think we can, right? Can we? Because then how does this thing work if I want to square root each side? I think I had this exact same issue the last time I did something remotely like this. So phi is the work done to bring a positive charge in, but we do have a negative charge. So I think this negative sign being here is appropriate. They seem to be opposite sign of whatever the ring is charged at. It's positive, but I wonder why. If we take them to have opposite charges, we're doing negative work and bringing them together. But the velocity, it is decreasing. We have a negative velocity. Because x is getting closer to 0. Oh, the square root of or the squared square root stuff is so weird. So it's still like, but this is like, I feel like this needs to be fixed from that r squared square root thing. And somehow justifying that should be a negative r in there. Hey, Viv. The theorem, apostle, or method? I got you in love with... I know what the apostle part is, but... I fell in love with math during high school when I was just talking about it earlier this stream, but I fell in love with it in high school when I was taking calculus and physics at the same time, and I realized that even though my physics class wasn't saying it, the equations we were learning come from calculus. And being able to see that direct application there was really cool. Benbox is saying it's supposed to be minus a half v squared. Oh, axiom, okay. No worries. Why would kinetic energy be negative? What does it mean to have negative kinetic energy? Ugh. The sign is on the potential side, okay. Antimatter is technically negative mass. Fair. It must be the r squared with the square root, but how can we possibly justify making that negative r? Like, physically. Well, yeah, the minus q is why I was putting the minus sign there in the first place. How potential energy is related to kinetic energy? They sum to 0. They're supposed to have opposite signs? What I should have written is I should have added them and set them equal to 0. Bro, okay. Is it that simple though? Should the energy be 0? I guess it should be, right? Change your kinetics equal to... Oh, okay. I guess that makes sense. Okay. All right, back it up. I was thinking that they should both be 0. Like, but the potential energy right at the center is 0. That's why I was doing it the way that I was doing it, but maybe that's wrong. I guess we take the negative root for the reason that I said before with x is decreasing. No, two. The two cancels. And I assume this thing is going to be undergoing harmonic motion in some way, and that seems like something that kind of came up with harmonic motion problems before. The sum of the changes are 0. Maybe that's what I was getting it confused with. I'm going to the back of books. I want to see a couple things. That's stuff that, like, I definitely learned in my mechanics class, but I've forgotten all of mechanics, so I feel at a bit of a disadvantage when they involve mechanics here. But yeah, that's something I probably should have realized. I should have written delta U plus delta V equals 0, but either way, they either start at 0 or end at 0, so it's going to end up just being their whatever the relevant quantity is. So the value for E, they said Q, capital Q, X. Okay, I wrote mine in a different form. If you convert my thing into total charge, it matches. Okay. If X approaches infinity, this thing looks like a point charge. Okay. How does X approach infinity and you still have an X here? Oh, they're using an approximation. I see. They're just saying the R squared is insignificant as X gets big. Okay. They're not literally doing the limit as X approaches infinity. So we're components here because the potential is a scalar. Potential. Oh, that's right. Potential is a scalar. That's why we didn't need cosine phi. Okay. Okay, that's a really simple way of justifying all that differential stuff that I ended up getting the same result in my head, but I didn't exactly go through all the reasoning that the answer does here. And that does match my answer, right? I did it with the linear density again, but it does match. Oh yeah, Obi. We are we were basically we had a formula that was given to us in terms of Cartesian coordinates, and we're thinking about converting it into cylindrical, except in cylindrical the R and the Z in this problem we're given would have been fixed, and I was getting confused on like the semantics of that. But the way the book does it ignores all that. Because it's all for the sake of finding out the total charge, and the total charges was easy to calculate. So I think we're just doing it the hard way. So that was the first major thing I wanted to see. The second major thing was part D. Initial kinetic and potentials are both 0. Okay. And of course, I did mine with the linear density. Does mine match though? Q, or no, sorry. Lambda is equal to big Q over 2 pi big R. So this does match, okay. If the radius of the ring approaches 0, then velocity approaches infinity because it becomes a point charge. And you get asymptotic behavior, okay. If R approaches infinity, then V approaches 0. This is believable and not entirely obvious. If we had a ring with constant linear charge density, do we not have a constant linear charge density? What do we have then? Okay, I don't know what that last sentence means, I guess. But if you do have a ring that's infinite with, like, you know, a huge radius, it's going to barely be affecting our charge, I guess. So there's not much, like, potential to build up against. I don't know. It's a neat consequence from the velocity formula you never would have thought of checking. Oh, wait. That's what I did on the board. R got removed from my answer. I don't know why they're saying instead. We are given that it's a constant linear charge density, I think. But yeah, in my last line there is no capital R. And I think that's what they're saying. Oh, maybe they're saying it's not constant because they're letting big R vary, and that's... If you kept the density constant as you increase R, that's what they're saying. Okay, now I get it. I think. Dude, I'm just going down the list right now of these questions. What does 13 say? If charge density wasn't constant, then the minus Q charge wouldn't stay on the x-axis as it moved. Agree, Fembox, yeah. Well, they're not talking about like a varying charge density where like one part of the ring has more charge than the other. They're talking about as the ring expands, you are losing like charge per length unless you increase the charge proportionally. And I think that's what they were saying. Use the technique from the second example in section 2.6 to calculate the potential of the center of a sheet in the shape of a regular n-gon with surface density charge sigma. Oh, okay. When I saw the title of this problem, I thought like there would be one charge at each vertex. You know, they're talking about a continuous distribution. So it's like filled in. Let the distance from the center to the midpoint of a side be A. Oh, this is gonna be kind of neat. It's gonna be like the Archimedes estimation for pi, with having a increasing number of sides of a polygon to approximate a circle. What's the second example in section 2.6? It's the first example. It's the second. What? Oh. This was not an easy example for me to follow. Oh no. So example 2, or this example, finds the potential on the rim of a disk of charge. And if you can't tell from the diagram, there's some geometry you have to do to work this out. I don't know if I want to do this problem now. I wonder if having a polygon is going to make it simpler, though. I'm going to re-go through this example again. Find the potential at a point on the very edge of the disk, such as P2. P2 is off to the left there, but to calculate the potential at P2, we can consider the first thin wedge of length r and angular width d theta. Bad boy right there. An element of the wedge, the black patch at distance r from P2, contains an amount of charge dq equals sigma r d theta dr. Because r d theta is the width of the top and the bottom, and dr is the width of the side, and we're calling it about a square. So you multiply it by the charge per area. Its contribution to the potential at P2 is therefore dq over 4 pi epsilon naught r equals, that's just the formula for potential. But now we plug in dq for sigma r d theta dr. The contribution of the entire wedge is integrating that from 0 to small r to be that thing, d theta. But this big R depends on theta. Okay. My confidence in being able to do this problem is plummeted. I still want to try it though. Wait, what's equation 2.27? Ooh, okay, it'll reduce the potential at the center of a disk. Okay, cool. Okay. Why is this barely not fitting? Fine. Have it your way. Doing it for an arbitrary sided polygon is going to be a little bit weird as well. Don taking my confidence. I'm gonna need it. Actually, wait, are we finding it on the rim or are we just using that technique? Potential at the center of a sheet. Maybe this isn't so bad. Let's use a hexagon, I guess, as our arbitrary sided polygon. So we're interested in the center. We're calling that distance A from the center to the midpoint. So this might not be so bad. I think what we're going to do is make it an isosceles triangle with each side. We know the height of this isosceles triangle, and we know the apex angle of the triangle to be 2 pi over n, the number of sides. They're using capital N, aren't they? Yeah. So what do we want? We want the area of this triangle because that would allow us to get the charge contained by that triangle. And why is that a good thing? Because that would be the numerator in the formula for potential, I think. And we multiply it by the number of sides, I guess. Okay, so the base angles of an isosceles triangle are the same. Pi minus 2 pi over n over 2, which equals pi over 2 minus pi over n. And we can use a right triangle to figure out the base of the isosceles triangle. So sine of pi over 2 minus pi over n, which I think is cosine of pi over n. "3D geometry keeps beating my ass because I don't know my terminology." Oh yeah, there is a lot of terminology in there. Sine of pi over 2 minus theta is cosine theta. Okay, good. Like the names of shapes and stuff. Why am I taking sine? I want tangent. Is tangent of pi over 2 minus something helpful? It's equal to cotangent. Okay, that's not the right tab. Tangent is opposite over adjacent. A over half of the base. I'm calling that B. So we can say that B is equal to two cotangent pi over n over A? I think it's times A. No? Wait, this entire thing is flipped, isn't it? I think it's 2A over cotangent pi over E. Cotangent is low-key slept on. I don't know. I'm okay with continuing to sleep on it. So what was, that means the area is 1/2 times height A times base 2A over cotangent pi over capital N. Sleep on it. Oh, caught. I get it. Okay, that was funny. Flew right over my head though. So I can say like A sub triangle. The charge in this triangle is sigma A squared over cotangent pi over N. So I think what all this is the numerator. We need to figure out what R is. How do they figure out what R is? You sleep on a ton of cot? I think they put R in terms of theta. I wonder if I jumped the gun with doing this total area calculation. It'll still be helpful, but maybe I should have started with what they started. Do we even need this area? um... Okay, let me do a separate drawing. Let's make a wedge. Let's take that little patch of the wedge. dq is equal to sigma r d theta dr. Or pi epsilon naught r. I should have, it's not right to have this statement here without an integral, but I'm just going to ignore that. So what does r range from here? It goes from 0 as far out as the end of the isosceles triangle. That's what we need. We need the length of the side of the isosceles triangle in terms of A. Hey, Sunche? Yeah, please do ask a question. You can type out there in chat. Or you can put it in my Discord if that's easier. Oh, Nash embedding theorem? It sounds like something I wouldn't know. I haven't heard of it before. Okay, I see Riemannian manifold and I quit. No, no, bending. I think this is beyond me though. My background is I have a bachelor's in applied math. This seems like it's something that is using math that I am not even close to have learned yet. Yeah, I believe that is cool. I hardly even know how to read this summary here, though. The Finnish word for a lateral surface? Sure, syntax. Yeah, I'm sorry, Sanjay, that I'm not able to help you out with this, but I'm sure it is something cool if I was able to understand it. The same word for diaper? Really? That's so weird. Is that a coincidence? Do I have recommendations for learning compressed sensing? I'm so sorry, Sanjay. I'd never even heard of that before, so I don't have a recommendation for it. Engineering undergrad, you'll be learning signal processing. Oh, interesting. Yeah, that sounds like cool stuff. I never studied that for myself though, so I have a hard time like commenting on or even helping. Not Googling extensively about diapers. I mean, sometimes there's some funky words for things in math, which is why I asked if it's a coincidence or not. Yeah, that's fair, Sanjay. Start getting some parenting ads or something. Sometimes those ads are weirdly accurate. Like I look at something on one website, then on an entirely different website, I get an ad for that thing. Solve it, do something. Should I dance for you too? Is that all I am to you? Just like a dancing monkey? That's okay, I'll be a dancing monkey. So I think we want to take sine of this angle. A over, I'm just going to call it H. Sine pi over N. You know, the most targeted ad once it was scary equals something you had an ad for it used. Oh, I hate that. So the R's are going to cancel, and that dr integrates from 0 to this. So I'm just going to, I'll write it out. Cosine pi over N. Okay. Now theta. I think how we're going to deal with theta is theta is gonna, I think now we get to use, we're gonna use 2 pi over big N, I think. You're not explaining anything, it's boring. Then leave. I don't care. I think what I'm going to do here is I'm going to, this is such sloppy math. Like I shouldn't be saying, I shouldn't just randomly put an equal in integral here, but I'm going to do it. 0 up to 2 pi over N. And we need to multiply it by N. Sigma A d theta over 4 pi epsilon naught cosine pi over N. You have to later show N to infinity. Yes, Sunshade. That's what I'm kind of worried about this sum as N goes to infinity. I don't know how it's going to work out. And yeah, John Reed, I agree. I'm not sure exactly what's happening here, to be honest. And I'm also wondering if this N depends on theta. I feel like it doesn't. And that'll make this integral a lot simpler. Some people are not real. Yeah, right. What is that syntax? There's a dude over in the YouTube chat who was saying this is boring, why are you solving anything, when I feel like it's pretty good evidence that I'm solving something, but evidently not for that person. And basically all this integral does is multiply this thing by 2 pi over N, which I guess is going to cancel with that N in front. And the 2 pi will cancel with the 4 pi. So what do we get? Sigma a over 2 epsilon naught cosine pi over n. That seems too simple. But if n goes to infinity, this thing, cosine of this thing goes to 1. Sigma a over 2 epsilon naught. Does that match with the result that they reference? Coco Melon is a children's channel. Oh, that would be much more suitable for that person's taste. What's your favorite mathematician or favorite math theorem or equation? That's a good question. Actually, someone asked me that exact one a little bit before, funny enough. If I have to do just like one like math theorem, I would probably I don't even remember it that well now, but I do really enjoy multivariate calculus and Green's theorem, and how Stokes' theorem is an extension of that. I really don't remember it well enough to be able to talk about it though, unfortunately. But the thing that really made me like math is seeing in high school how the things I was learning in my physics class, or I was taking physics and calculus at the same time, and I realized that the things I was learning in physics class are based on calculus, and seeing that connection really like was cool to me. So I guess there's 2 slightly different answers for you. Sorry you had to punch out 2 depressive reforms. I think I'm just having a lucky day. Sigma a over 2 epsilon naught. Wow. Okay, I don't know what crazy shit I was doing on the upper right side of the board that I partially erased. I just wanted to get the area of the triangle. But that didn't turn out to be helpful. All I had to do was just blindly apply this calculation almost the exact same way. So once I actually started doing that, it flowed a lot easier. And hey, Srivatsa, you want to improve your math speed? What should I do? I haven't trained my math speed specifically, but I would think just like almost any type of math, it's just going to be a lot of practice. I've seen people doing, if you're talking about like mental math, I think like a Zeta Mac. Yeah, like this website, it will give you like a lot of mental math, like speedy, like drills you can do if that's what you're interested in. But if you're talking about in general, like solving problems from your class faster, I would just say do a lot of them. It's showing me a bit in physics after you learn calculus, and I got. Oh, awesome, Sanjay. Thank you very much. Hope you have a good day. No, and complex sum? You're talking about like complex numbers? Yeah, I don't know if there'll be a website like that then. Yeah, like my issue with algebra-based physics is I don't like things that involve memorization. And there's much less memorization involved when you're doing things with calculus because you just kind of derive it naturally, I feel like. There are some formulas in here that you should know. But it's way less arbitrary, it feels like. You can figure it out for yourself. Forgot to open the YouTube stream? No worries, Joseph. P-ish just asked a question. Sine over the absolute value of sine plus cosine over the absolute value of cosine plus tangent over the absolute value of tangent. All 6 of the trig functions divided by their absolute value. And you're summing them all together. Wait, you have r squared over 3 pi. You're allowed to factor to r over 3 squared. The 3 would need to get square rooted if you're bringing it inside. So you can say it's r over root 3 in parentheses squared. Same with the pi, I guess, if you want to bring that in, but if you bring a number that wasn't squared underneath the squared, it needs to get square rooted to compensate. Or, wait, is that not what you were asking? Maybe I might have misunderstood your question, but I don't know now. Pish, I'm thinking about your question. Oh, you're estimating it as 9? Oh, I wouldn't allow it. It's probably allowed, though, depending on the context. Find the values in all 4 quadrants, then draw its graph. I mean, it depends on the context whether that's allowed, I guess, syntax. I don't know. All right, let's see what's up with this question that Pish put. I don't want to erase this because I haven't looked in the back of the book to verify it yet. I can erase this stuff up here, though. So Pish is saying we have sine of x over absolute value sine x plus cosine x over the absolute value of cosine x plus tangent x over the absolute value of tangent x plus, I mean, I should probably match the order, right? Cotangent, secant, cosecant. This is kind of a cursed problem. Ah. Okay, so you need to find the value in all 4 quadrants. Yeah, I figured it'd be a little bit more natural if I matched the order that you wrote it, but it definitely doesn't matter. Deadbox is saying 6 in quadrant 1, minus 2 in all the others? Ooh. Currently you're in 11th grade. I'm not good at understanding. It's very hard calculus. Oh, yeah. Calculus, especially for the first time, is really, really difficult. In quadrant 1, these are either 1 or -1, right? So sine is positive, cosine's positive. These are all positive. That's just how quadrant 1 works. 6. In quadrant 2, sine's positive, cosine's... Oh, this is really just like an understanding thing, I feel like. Cotangent is negative. Secant is negative. Cosecant. Wait. Is cosecant 1 over sine? That's what it is, right? Yes, it is. Okay. For some stupid reason, cosecant doesn't go with cosine. But anyway. This comes out to be -2? Does that match with what Femluck said? Okay, yeah. In quadrant 3, sine becomes negative, cosine is still negative, tangent is positive, cotangent is positive, the others are negative. Okay, so that's where this pattern is coming from. In quadrant 4, sine is negative, cosine is now positive, which means tangent is negative, which means cotangent is negative, which means that secant is positive and cosecant is negative. So, okay. Now, technically, this isn't defined x can't be 0, n pi over 2 I think that's all. Oh, yeah. It can't be 0 or n pi over 2, I think, because then we get discontinuities. But I think from here the graph becomes a bit more clear. It's going to be like a really weird step function. So I'm going to say these are multiples of pi over 2. 1, 2, 3, 4. For 0 to pi over 2, it's positive 6. Open circles, importantly. And then from pi over 2 to 2 pi, it's negative 2. And this is going to repeat for every other quadrant. So you basically like repeat that pattern left and right. Goodbye marker. The range be okay. Yeah, so in that case you wouldn't need to repeat the graph either. But I'd say that's your graph right there. What do you mean you haven't memorized your DLC one trig functions? Let me know if you have any questions about that, P-ish. There are some super vague trig functions out there. Like I looked at the Wikipedia page for it once. I don't remember like what any of them are called. But they used for like it's called like surveying or whatever, where you like figure out the angles of the land and stuff. Have or cosine, yes, stuff like that. And hey, Yakshit Tayel, I'm probably saying that wrong. Why -1 times out of -1 is +1? There's probably a better explanation than this. I just haven't memorized that a negative times a negative is a positive. For an actual intuitive understanding of why that is, I don't actually have one now that I think about it. That's something I ever questioned. Hyperbolic trig is actually sick. I barely had to use it. It was never formally taught. Like sometimes professors would randomly throw a problem involving hyperbolic trig. But we never actually like taught it. Oh, okay. And syntax error is giving a metaphor for that negative times a negative, which is if you multiply by a negative, it's like you're turning around. So if you do negative times a negative, it's like you've turned around twice and you're back to positive. Yeah, I don't have the best explanation for that myself. And PH is saying if you add cosine over secant and sine over cosecant, it's really difficult. Yeah, you're not getting constants there, unfortunately. It's not always going to be 1 or -1, is it? Yeah, that's what I'm thinking, is you would get like a sine squared and a cosine squared kind of in there. Express 234 in terms of a to the b times b to the a? Um, I think Piyush, I haven't quite worked out, like, is it going to be exactly cosine 2x that you will get from the identities there? If it is, I think you could do, like for this, you do cosine of 2x plus 6, and for this, you do cosine of 2x minus 2. So instead of having a straight line, you're going to have like part of a cosine wave. Something like that. This isn't quite right. It's getting a lot more complicated though. I don't know, it'll be something kind of curvy like that, but I can't quite work it out. Its integral derivative are the same, but also its arc length and catenary. Interesting. In Yuck sheet, I think my only idea to do that is to get the prime factorization of 234. I've heard people ask about JE. I don't know much about it though. Oh. Yuck sheet. I don't think there's an integer solution for that. There's probably some real number solution for that, but I don't know how you would do it. A to the b times b to the a? Or rational number, maybe, I don't know. I mean, I've looked at it briefly before, Piyush, but I'd rather, like, if someone has a specific question, I'll let them, like, ask me. What do you think about math and computer engineering? Is it interesting? I think it's interesting, yeah, Malik. I don't know very much about it, though. I did do a minor in computer science, and there was some kind of cool number theory tricks where I got to see them be applied to a real situation, and like learning how to count in binary and hex is cool. As well as like logic gates and all the things that go along with that. I think are interesting parts of that. I mean, Yakshi, I don't really know how to do that. Are A and B integers? Because I think it's an impossible question if that's so. No worries, Malik. I don't check my answer for 2.13. That looks familiar. That matches. A over cosine theta. Good. Oh, they don't figure out what theta is yet, I guess. Okay, yeah. Now they get pi over n. Wait, two n triangles. An n-gon consists of two n triangles. Oh, they're talking about right triangles. Not isosceles triangles like I was making. Okay. Oh. Wait. I didn't get the right answer. No. Pi over n does depend on theta. I thought it would be weird to have it as a bound and a dependency. So like, oh, okay, it's probably fine to just not care about it. Oh, it's a trick question. Okay, yuck sheet. Yeah, I mean, that, okay. That's fair. I did not think of doing that, so well played. Um, as n approaches infinity. Oh, they're doing sine of x approximates x for that thing right there. Oh wow, okay. Hey, Mayank Verma, how's it going? Yeah, Yakshid, I get it now. Indian civil service exam? That seems like a weird question to ask. It's so weird that I still can't quite. Pi over n. It still doesn't quite sit right with me that pi over n depends on theta and we're integrating in terms of theta. Isn't that? I mean, I guess that's fine in math. You just use a dummy variable and they don't care about dummy variables in physics. Okay. Other than that, though, I had the right idea. I just didn't interpret this one piece quite right. Okay. I think I might wrap up the stream here though, because it's just hot. And I'm getting tired. So yeah, I'm gonna show the YouTube stream off here. On Twitch, I'm gonna go raid out to someone. But if you're on YouTube, I appreciate you. What time do you conduct streams? Tuesday, Thursday, Saturday, starting 3 hours and 40 minutes ago, whatever that is in your time zone, at 1 Pacific time. Oh, thanks for the sub. Yeah, thanks to the people here on YouTube. I'll be back on YouTube on Saturday, and we'll be doing a physics reading group and then math help. Explain the meaning of independence and probability. The man guy, I do want to wrap it up here, but the quick explanation is that if two events are independent, it means that the outcome of one doesn't affect the outcome of the other. No, I don't teach anywhere. I have been a tutor, but I'm not a teacher. Oh, if you're one of the people who joined the Discord, I mean, I don't have much of a better answer for you than that. Like, it's just... It means that the two events are completely separate. Like, one doesn't affect the other. If you have a probability question, please feel free to post it in there. But I guess that kind of is the explanation. Things actually, but I'm trying to make this streaming thing work. So I am gonna head out. So thank you both for being here. And to anyone else on YouTube, feel free to post my Discord if you want to reach me. But yeah, see you around. Yeah, what John said.